In this video, we're going to talk about ellipses. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, which we call foci, which is the plural of focus, is constant. So if we're dealing with an ellipse, and this isn't necessarily going to be to scale, but an ellipse has two foci, two focuses that it wraps around. And the idea here is if I drew a line from one focus to the edge and connected to that other focus, the sum would always be the same. And so what I mean by that is if I drew a different line, and again, this isn't to scale, but the sum of these two purple lines would equal the sum of these two red lines. Easy way for you to think about it is if you had two thumbtacks and you stuck them in the paper, right? And they were securing in place a loose piece of string. Well, if you took your pencil in that string and pulled those little bits taut, say here's my pencil right here, pulling it taut, and I took my pencil and I rotated it around, that would give me my ellipse around those foci. So when we're dealing with an ellipse, we're going to have two foci. We'll have a center that shows up in the center of those. And then we'll have two vertices. And the vertices will all be on the same line. So we've got these major vertices, foci, and center. In this situation, they're all on a horizontal line. And this is a horizontal major axis ellipse. We also have a minor axis. So that would go up and down off the center, and they would give us these minor vertice points. All right, so that's the idea of what an ellipse is. Now let's talk about our definitions for, defining and writing the equations of ellipses when they're centered at the origin. And then coming up, we'll talk about the transformation versions. So here, we're going to look at the standard equations for ellipses centered at the origin. One has a horizontal major axis, the other has a vertical major axis. So that's the orientation, horizontal or vertical, just like when we were dealing with parabolas. Now, circles didn't have an orientation because they're the same length and width, it's just a circle. But ellipses are going to be longer either horizontally or vertically, maybe not that noticeable, but there will be that difference. So I'm going to write this out. A horizontal major axis ellipse is going to look like x squared over a squared plus y squared over b squared. And that would need to be equal to 1. Whereas a vertical major axis ellipse could be written as x squared over b squared plus y squared over a squared. And again, equal to 1. So you'll notice that these look very, very similar. We just have these two different values here in the denominator. Now, it's very important that we recognize the difference in these two values, and this is always going to be the situation. A is larger than B, which is larger than 0. So these have to be two positive numbers, and the larger number being under X means it's horizontal. Over here, when we have the larger number A under Y, it is vertical. All right, so this is a really important key for us to remember. The larger number is under X for a horizontal, and the larger number is under Y for a vertical. So an ellipse is like a circle. We have both x squared and y squared, and both of the signs are going to be the same, either positive, or both negative, both pluses in front or both minuses. The difference is they have different coefficients. So we'll have a squared and a b squared, which show up in our denominator. Now I'm just going to reinforce here that both of these are centered at the origin, and that means the center in both of these situations is 0, 0. All right, so let's look at taking this information and writing our attributes for a horizontal major axis ellipse. So the vertices, A is the biggest number. A represents the furthest distance off of the center. Since we're dealing with a horizontal major axis ellipse, my vertices are going to be changes in the x value. So I'll have 2 points, positive and negative A, comma 0. So my minor axis is going to be vertical, my shorter axis, and that's going to give me y-intercepts. So I'm traveling up and down b units, or plus or minus b. And then the last piece here, the foci are on the same major horizontal axis as the vertices. The foci are found by using this number c. So we're going to say plus or minus c, comma 0. Now, you can see there's no c given, and that's because we always have to calculate the c value. And the way we calculate it is that c squared equals a squared minus b squared. All right, so c squared equals a squared minus b squared. So I think, okay, well, an ellipse, these have pluses. And again, you don't know about hyperbolas yet. That's our last conic. But hyperbolas are basically separated by a minus. And the hyperbola formula has a plus here for c. So the ellipse has a plus, the c formula has a minus. And we're going to see something very similar but different, same, but different, for our hyperbolas when we get there. All right, so let's talk about this. What does this look like if I were to graph it? Well, we're centered at the origin. There is my center. And my vertices, because this is a horizontal major axis, I'm traveling out a units to the left and a units to the right. So that gives me an ordered pair, negative a, 0, and positive a, 0. The foci, those are going to be calculated somewhere in here, and those are from my C. So I'll have negative C0 and positive C0. And then my minor axis, and I'm drawing this really exaggerated, but my minor axis is going to be the short axis. And that's up and down B units. So I have 0, comma B and 0, comma negative B. Main thing you guys want to know is we have 2 vertices and 2 foci. And again, they're all occurring on this longer, as we say, major axis. So this ellipse, and this isn't going to be the most beautiful, might look something like this. This is my horizontal ellipse here. Again, paying attention and noticing the fact that all of these main points are occurring on this longer major axis. So now that we have looked at those attributes for our horizontal major axis ellipse, let's compare the difference between a vertical major axis ellipse. So again, my vertices, I use the A value, the larger of those 2 denominator numbers. I use that A value to give me my vertices. But since we're dealing with a vertical major axis, instead of having that A value be in X, the A value is going to be in Y over here. So I've got 0 plus or minus A. Those are on the Y axis, or they are Y-intercepts. We then have x-intercepts on our minor axis, and those are coming from the smaller of those 2 numbers in the denominator. So that's plus or minus b comma 0. Again, noticing B is in the X location. And then the foci are on, again, my major axis. So the foci come from C, A squared minus B squared, and that C change is going to occur on my vertical major axis or in Y. So I have 0 plus or minus C. So let's look at what these look like for a vertical ellipse. Again, we have a vertical major axis. So most of my big changes are going to be occurring on this vertical axis. My center, C, is at the origin. Traveling out the farthest or the furthest in either direction, those give me my vertices. I'm moving up and down. So I have 0, comma positive A, 0, comma negative A. My foci are also going to be traveling out a distance on that major axis. I've got foci in either direction. I have 0, comma positive C and 0, comma negative C. So my minor axis, those are going to be shorter. If it was the same, we would have a circle. And they should be equidistant off of that center. So I'm traveling out negative B0 and positive B0. This gives me a nice ellipse. That is not very ellipsy. Do that again. That looks roughly like this. So one thing for us to note, which I didn't note for these, but the length of the major axis is 2A, and the length of the minor axis is always going to be 2B, that smaller number. So 2B is the distance off of that center. So let's look at an example of identifying an ellipse, listing its attributes, sketching the graph. And again, this is going to be an ellipse which is centered at the origin. Here, we're given this conic. We're asked to identify the conic, state its orientation if necessary, and then also any attributes. So we've got 9x squared plus 4y equals 36. So running down our list of things that we know, since there's both an x squared and a y squared, there's no chance that this is a parabola, not a parabola. So that means it is an ellipse or a circle or a hyperbola. We haven't learned about hyperbolas yet, but hyperbolas will have different signs. So notice that both of these x squared and y squared terms have positive coefficients. Hyperbolas will have different signs for their coefficients. This is not a hyperbola. That means it's either a circle or an ellipse. Circles would have the same coefficient. This is not a circle. This is an ellipse since we have different coefficients. Now, in order for us to determine orientation, we need to know where the largest number, or which x squared or y squared, has the larger number beneath it. So what I'm going to do is begin to put this in standard form. You'll notice that the standard form for each of these ellipses is going to be equal to 1. So I'm going to divide everything by 36. That gives me this equation. X squared, 9 over 36, reduces to 1 over 4. So x squared over 4 plus, we have y squared over 9 equals 1. So now it's in standard form. And because the larger number is under y, we have an ellipse with a vertical major axis. The larger number being under y told me vertical. Now again, going back, you'll notice that both of these terms are a number squared. We have a squared or b squared or a squared. We need these to be in their root form. So I'll rewrite this. I'll say x squared over the value 2 squared plus y squared over the value 3 squared. And again, that's equal to 1. My larger number is A. A is 3. My smaller number is 2. B is 2. And when we want to calculate our C value, we use a formula. We calculate C using a formula. C squared equals A squared minus B squared. So we have a very similar C formula for hyperbolas. Hyperbolas has a plus. I remember plus, then minus, and then hyperbola would be minus and then plus. Just trying to give you guys the mnemonic devices or the things that I use to know this so well. So this means that C squared is 9 minus 4, or C squared equals 5. That means C is plus or minus the square root of 5. And since we'll be adding and subtracting that C value to get our two foci, that makes sense. So C is plus or minus root 5. So as we go about graphing this and listing all of the attributes, I think it's helpful for us to, do them both simultaneously. So I'm not going to just list my attributes and then graph, or graph and then list. I'm going to kind of work on them both at the same time. All right, so moving along, we know that this is a vertical because the larger number was under y. This is a vertical oriented ellipse. Now, in this case, there's no x or h or k value added to that x or y. This ellipse is centered at the origin 0, 0. The foci are always formed by plus or minus C. Since it's vertical, my C change is going to be on the major axis. That's going to be up and down on the y. So I have two foci, 0, square root of 5, and 0, negative square root of 5. My vertices also on the major axis, those come from my A value, which I see here is 3. So I have 0, 3 and 0, negative 3. All right, so we're just thinking about this. My center is at the origin. I'm going to count by 2's out on my axes, so it gives me a little more space. I'm going to count up 3 and down 3 units. Again, I'm counting by 2's, so my graph doesn't show up really tiny. So my major axis is vertical, and that means my big changes, my focus and my vertices are stretching out along that vertical y-axis. So up 3 units and down 3 units, those are my vertices. I have a vertice at 0, positive 3, as well as a vertice at 0, negative 3. The foci are also on my major axis. Square root of 5 is roughly 2.2. So I have one foci up 2.2 units off the center and one foci down 2.2 units off the center. Now my minor axis, my shorter axis, which is the shortest of them all, is 2. That 2, I'm going to be traveling out 2 units to the left and 2 units to the right. So my minor axis vertices are plus or minus, positive and negative 2, 0, on my x-axis. The axis of my major axis, the length here of that axis, that's going to be 2 of A, or 6 units, whereas my minor axis is 2 of the B value, or 4 units. Therefore, I can draw my ellipse. Try to make it look as nice as I can here. And this is roughly what it looks like. So we would be listing vertices, center, foci for any ellipse that we are dealing with. I hope that makes a little bit more sense. Moving forward, all the ellipses that we're going to be working with in our notes or our lecture videos here, those are all going to be shifted off of the origin. So we'll talk about shifted ellipses next.